If you think an atom looks like this, you're wrong. To understand what an atom really looks like, we need to look at quantum mechanics.
We describe objects in the tiny world of atoms, like electrons, using wave functions. Imagine that this apple is in a random place every day. If we take a picture every day and put them all together, we get a map showing where the apple shows up the most. Using this information, we can make a graph where the height is equal to the probability. This graph doesn't tell us exactly where the apple is or going to be, but gives us a pretty good idea of where it might show up. Electrons are also represented with this kind of graph called a wave function, which isn't like a physical wave, but is a probability graph like the apple graph. By taking the wave's height at any point and squaring it, you can calculate the probability of finding the electron there.
And now there's some weird consequences for this wave function of the electron. One of them is that it can only have certain energy levels, but not others. This is called energy quantization.
Let's look at this piece of string bound at both ends with waves on it. The energy of a wave is directly proportional to the distance from one wave to the other. The lower the distance, the higher the energy. These are all the possible energies we can have with our wave on our string. Notice how you can't have any energy in between, since those waves would not fit on the string.
This principle also applies to the wave function. Just like the string, the wave function of an electron can only have certain values, because nothing else could fit inside the atom. This means that the wave function can only have certain shapes.
So let's understand what all this means for a model of the atom. We're going to model the atom like this, with a brightness corresponding to the probability of finding the electron there. In a three-dimensional world, the different energy levels of the electron corresponds to these shapes for the wave function. Notice how at each energy level there could be different shapes, depending on the orientation of the shape. These shapes are called orbitals. We can now understand what an atom looks like. Instead of this, we have a tiny dense nucleus with an electron cloud surrounding it. This cloud has different shapes depending on the energy levels of the electrons in the atom, and it shows a probability of finding the electron there. It's not what we expected, huh?